All right, so this is a little note on cooling power. So schematically speaking here, I've basically just shown the dewar, the lines that connect the dewar to the rest of the system, the chamber, and then the chamber itself. All right, so when we're taking cooling power, what we're essentially doing is measuring how fast the cryogenerators are gonna cool down a certain amount of gas, right? And in order to facilitate this, we have written a MATLAB script that essentially estimates the volume of the dewar and then takes the data output from our cryo system monitoring VI and tells you what the cooling power is. But in order to get the cooling power, you need to essentially run the cryo system until you're at a high enough pressure that you can have the cryogenerators pumped down over a sufficient pressure range so you have an idea of what the cooling power is, right? So schematically what happens is you run the system in pump mode, and in order to do this, the system needs to be at rough vacuum. So you should have, to this point, roughed the system down, done a leak rate check, all that good stuff. You're below the 0.1 or 0.2 millitorr, so now you're ready to take cooling power and then presumably continue on the rest of the pump down. So the cooling power is going to be taken on the very first cycle of the cooling process. So the very first thing you're going to do is come over to the Stirling control box and set it to pump mode. All right, and then what's going to happen is you're going to see the pump turn on. You're going to see the gate valve start actuating, and then that's how you know that you're flowing out to the cryo system. So, that you're flowing out to the chamber. All right. So what's going to happen is, or right now, what's happening is you're flowing liquid nitrogen out to the chamber. It's going to exchange heat with the shrouds, and then gas is going to come back. So the pressure is going to build up to the point where once the pressure in the dewar gets to about 10 bar, the pump turns off. So once we hit 10 bar, we're going to go ahead and we're going to go ahead and set the system into idle mode, set or close 61.21. Right, so at that point, what you've done is completely isolate the dewar and cryo system side of the chamber system from the actual chamber itself. However, when you're doing this, or when you've done this, you're essentially only compressing the gas that is connected to that's in the dewar and is in this part of the lines. So all the gas that's coming back from the chamber needs to be evacuated, or else you're going to get a huge pressure buildup in those lines. So the next thing that needs to happen is once you close 61.21, you need to open 61.22. And schematically, what 61.22 is just a relief valve that is connected to outside. So this just releases the gas that's coming back from the chamber to the outside. So I'll show a video of doing this whole thing, but this is kind of conceptually what's happening. So the very first step is to flow out to the chamber, get the pressure in the system up to 10 bar. The next step is to set the system into idle mode and then go out and close 61.21, okay? And just by virtue of going into idle mode, 60.21, which is the gate valve, the automatic gate valve, also shuts. So then you've isolated the cryo system from the chamber lines. Then finally, what you need to do is open 61.22 so that you're venting all the gas that's in the chamber outside so that you don't get a huge pressure buildup in the chamber.